So you just completed a problem with a two-digit factor times a two-digit factor, and you understand that when we multiply the first partial product, we're multiplying the ones, in this case the 3 times 2 to get 6, 3 times 8 to get 24, and then when we're done multiplying the ones, we can cross that off and get rid of it, and we need to bring down a 0 as a placeholder, because now the 7 is the tens, and every multiple of 10 ends in a 0. So we multiplied 7 times 2 to get 14, regroup the 1, 7 times 8 is 56, plus 1 is 57, and then we add those two partial products to get the total product. And you're very familiar with two-digit times two-digit multiplication. So what do we do when we have a three-digit multiplication problem? Here we have a factor with 3 digits on the bottom. I've multiplied the first 2 digits already, the ones. 4 times 5 is 20, regroup the 2. 4 times 2 is 8, plus 2 is 10, regroup the 1. 4 times 3 is 12, plus 1 is 13. We crossed off the 4 because we've done multiplying the ones, brought down a 0 to hold that place since the 6 is in the tens. And then we did 6 times 5 is 30, regroup the 3. 6 times 2 is 12, plus 3 is 15, regroup the 1. 6 times 3 is 18, plus 1 is 19. So this is where we are right now, and you're very familiar with being able to do all of that. So now we're done multiplying the ones and the tens, so it makes sense that not only do we hold the ones place with a 0, but we also now have to hold the tens place with a 0, because this 2 is in the hundreds, and every multiple of 100 ends in 2 zeros. Now we're ready to multiply like we normally do. So 2 times 5 is 10. Going to regroup the 1. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. And then we're going to add those partial products. In this case, we have 3 partial products, and we're going to get 85,800. So the steps don't change at all. Just for every place we've multiplied and we've crossed out because we're done, we're going to be using a 0 to hold that place for the next partial